Hello everyone, welcome to the another very important session. So this will be our session in the series which is Path to Success for your upcoming CSIR NET and the GATE Physics exam. So guys, today we are going to start our discussion in this session for the mathematical physics most important topic, and mostly in every year now in the recent time we get a question from this topic. And as we have talked about it in our first announcement video about the series, that you need to check and you need to watch the sessions in this series regularly and you can't miss them because they will be helping you to work on the questions, to know about the concepts, to know about some tips and tricks, whatever will be possible to discuss in that particular topic discussion. So today we are going to talk about contour integration. If you are the one who doesn't know about anything related to this topic, this video will be helping you to be more confident about the topic as well as to know about how to work on the questions, what are the things you need to know, how you will be solving the questions and all that part, right? So just stay tuned and see a difference like in your confidence, how much you know about the topic right now and how much you will get to know. Same way in upcoming days we will be doing the discussion about more and more topics from different subjects. Okay, before this video I have already uploaded an announcement video, so if you know about that you will be familiar with the series Path to Success, because that will be helping you to cover up almost all the important things for your upcoming exam. So don't miss it and share the videos with your friends too. Like the videos if you like it, and to make the sessions more interactive you need to tell me what you are gonna like most in the session discussion we have done. Okay, like in this session whatever what we will talk about, same way what you didn't find that much clear, you were not able to understand, because that way I will try to include more and more such things which are helping you to understand in easy to understand manner. It can be some trick, it can be the way of discussion, anything. So you need to tell me your views in the comments, that's very important, okay, to have a better discussion in upcoming sessions as well as to do it as per what makes the things more clear to you guys. Okay, let's continue. So our today's topic is most important and from mathematical physics, that is contour integration. It's for everyone, those who don't know anything about it, and even if somebody already knows about it, for the sake of revision and to know that what different thing I'm going to talk about today in the session, just keep on watching this. So basically guys, when we talk about the contour integration, there are few things which are very important for everyone to know. The first thing I would like you to know or to understand is the pole. The second thing I want you to know is the residue. Also the understanding that what we mean by the contour and what we will be considering here for the contour, like that's what I'll explain. The third thing is the Cauchy's residue theorem. So these are the three simple things you need to know, okay, and they will be helping you to work on most of the questions. So what is pole? First of all, for that I'm going to take some examples to make it clear to you. For example, there is a function of z, because in contour integration what we will do, we are mostly going to find the integration of the function, right? So there is a function for which we want to find the integration. Let's say the simple function I'm going to take to introduce the pole, that is 1 over z minus 3. Okay, let's say for this you want to solve the integration. So in this case, what is pole? Pole is that finite value of z which will make the function infinity or not defined. So if I'm gonna see what I said, the finite value of z, because it's the function of z, right, which will make the function infinity or not defined. So how this function's value can be infinity? You know, if any function's denominator is 0, then it gives you the value infinity, right? So in that case, to find the pole, the easiest way is, if it is having the denominator, just equate it with 0 and see what are the different values you are going to get from the factors present in the denominator, and that way. So z minus 3, if you will equate with 0, you will get z is equal to 3 from here. So that is going to be the pole. Same way, if I'm going to take the example z square minus 4 or even anything else, you have to find its factors to know about the z values. So I can write it as z minus 2 into z plus 2, because that will give me z square minus 4. This is going to give me z is equal to 2 if I will equate it with 0, and z is equal to minus 2 if I will equate it with 0, right? So in this case, you got the poles, right? I have just shown you how to find the pole. And what is the meaning of pole? We also talked about that. Even if there is a possibility that there is some value in the numerator, and after you put or plug in any finite value of z there, it still gives you the value infinity. Okay, so we can take the example of log z. Just check out what is the log 0 value. If in case you get infinity for this or for any other case, that will be even your pole. But the thing is, it is gonna be rarely in the questions we got till now, but I'm still giving you idea about it. If in case you're gonna observe it somewhere, you should know that. Okay, so now after knowing about the pole, we need to talk about the order of the pole. So what is the order of the pole? The overall value of that factor which is helping you to get that pole is the order of the pole. So for example, its power is 1 here, so its order is what? That's 1, right? If we are going to talk about this and this, that's 1 and 1. So in that case, z is equal to 2 is order 1 pole, and z is equal to minus 2 is also order 1 pole. Or even if you will observe the overall term here, its power is 1. So that is also giving you the order 1 pole, right? So I hope guys it's gonna be clear to everyone. But still, if there is someone like who's not able to understand it, you can mention it in the comments. I will even try to have a session where I will be taking your doubts in terms of like what you have mentioned in the comments in the different videos I will upload. So after some number of sessions, I can consider a doubt clearing session in which I'll be taking your doubts which you will mention in the comment section, right? Now, so order, I hope it's clear. The pole, I hope it's clear. But still, if there will be doubt, you can mention it in the comments. Now, once you got it, guys, next thing is what is the residue? Okay, one more thing to explain the order. For example, here the power is 5 given to you. So what is the z is equal to 3 pole order here? So that will be 5. So order 5 pole we had, right? Now, once you got it, you need to understand the concept of residue. But I would like to mention one thing here, that is that if you are going to find the residue for any particular order pole, so in that case, you need to know that you will be just using the pole which will be lying within the contour. You have to work on that pole which is lying within the contour. That's very important point. Now, what is the contour? Contour can be a circle. For example, see such that z minus r or z minus c, let me just write it, z minus c as a center of the circle is equal to r. Okay, so it will give you z is equal to c if you will equate it with 0. So in that case, what will happen? Z is equal to c is the center of the circle, right? For example, the equation is z minus 1 is equal to 2. So here center of the circle is at z is equal to 1. So which is going to be somewhere here, and its radius is what? That's 2. So in that case, it's going to be here, right? So you are going to have minus 1, you are going to have and 3 here, because you can see the difference of 2 to value you should have here at these places, right? In this case, if we will talk about the next thing, so this is your contour, right? Now, if you are going to consider there is a pole which is you got, for example, z is equal to 2. So that pole is lying within this contour. You will work on finding the residue as a next step after knowing about the pole. Now, let's say you got z is equal to 5. So is it within the contour? No, you don't have to consider it. If something is related to the contour, you have to find the residue on that pole. But otherwise, if it's outside, leave it. You don't have to take that, right? It's very important. So mostly it has been observed, if somebody is starting to learn this topic, there are chances that they can make the mistake that even if the pole is not within the contour, they still work on it further to find the residue, use it in the Cauchy's residue theorem, which is wrong. So you have to be extra careful here that you don't have to take the pole which is not lying within the contour or not related to the contour given to you. It's outside it, okay? So you will not be finding the residue for that. Next step, that's the residue. So there are different formulae to find the residue, like for different order poles. For order 1 pole, we will have different set of formulae. For order n pole, where n is greater than 1, so let's say order 2, order 3, order 4, order 5, order 6, like anything greater than 1 order, In that case, you will have to use different formula, and there is a specific formula which is applicable for order 1 pole. Also, order 1 pole is known as simple pole as well. So there is a formula which is applicable for order 1 pole as well as order n pole where n is greater than 1. Let me just introduce these formulae, then we will be ready to start our discussion about the questions too. And there are different type of questions from contour integration you can expect. I'll be telling you what are these different type of questions, and we will talk about it. So basically, for the residue discussion, I need to tell you that if there is going to be a simple pole, first thing we will talk about is simple pole. Now you know what is a simple pole. Mention it in the comments if you can relate. So that's the any pole having order 1, we call it the simple pole, right? Now there are two formulae which are just specifically for the simple pole, okay, you to find the residue corresponding to it. That is, first one is the most popular one, and we will normally be using this, that says limit z tends to a, z minus a, fz, that is the function which is given to you. The in this case, whatever function is given to you which has helped you to get that pole, overall function we generally take, whatever for which you need to find the integration, okay, and z minus a you write in the starting. After simplifying this part, you apply the limit, right? So limit z tends to a, z minus a, fz. The other thing is, this is only applicable for simple pole, we mostly use it, but in any case if it is making the things complicated, it's not giving us the answer quickly for the residue, so we will go for the next one. That is, if there is a function which is having numerator and denominator, excuse me, so in this case for the simple pole you can also use the formula to find the residue, which I will talk about, but for that formula your denominator's value at the pole should be 0, but your numerator value at the pole should not be 0. Then only you can apply this formula. So as per this formula to find the residue at a simple pole, keep your numerator as it is of the function and denominator's first order derivative with respect to z, okay? And then just put z is equal to a. This will also help you to get the residue. So that's how you will be able to find it, okay? So now the next thing. If there is order n pole, then what we will do? So in case of order n pole where n is greater than 1, guys, you will have the formula that says 1 over factorial n minus 1 dn minus 1 dzn minus 1 z minus a to the power n fz. Now what you will have to do, so you will simplify this and then you will do differentiation and then you will plug in z is equal to a. This is only applicable for order n pole where n is greater than 1. Okay, you have to memorize the formula. You need to keep them in mind, and that will be easy for you to do when you will work on the questions by using these formulae too. So it will be helping you as well. Excuse me. Next one. For the simple pole means order 1 pole, and for order n pole where n is greater than 1, there is a formula which is common for both, but we will not always be able to use it. That's why we need to know separate formula too. So let's say z is equal to a's pole, okay? So then we assume that z minus a is equal to t. Excuse me, z is equal to a was what? Pole, okay? So z minus a is equal to t we are considering here. Now, you will try to remove z from everywhere. If there is only z present, plug in t plus a at that place. If there is z minus a present, plug in t there. And after simplifying it, the coefficient of 1 over t will be giving you what? That is the residue from the expression. That's it. This is what you have to do, and this is applicable for order 1 and order n, both the poles. Okay, that's something important. Once you got this, now you are ready to know about the Cauchy's residue theorem. What it says? It tells you about the integration over the closed contours. Closed contours, right? That says that 2 pi iota into sum of residue means whatever poles will be lying within the contour. In that case, find the residues corresponding to them and then find the sum of all those residues. Okay, so whatever they are. Also, this positive sign is for the anti-clockwise or counterclockwise direction of the contour. It's for anti-clockwise or counterclockwise, okay? Both have same meaning. But if it will be clockwise direction of the contour, then negative 2 pi iota into sum of residue, okay? Direction matters. Now, this was the basic introduction. So, initially you will find poles, you will see what poles are lying within the contour, you will find the residue at those poles, then you will apply the Cauchy's residue theorem. Now, once you understood that, okay, this is the process we have to follow and we need to consider if we are working on any such type of question, after this, what? After this, you need to work on few questions, okay? And what we will do, I'm going to share the questions with you. Let's keep the videos not too lengthy because in a go, like, then everybody will not be able to check them out. So right now I'm going to share some questions, and as I've mentioned during this discussion in this session, that if in case you will have any doubts, mention them in the comments. I'll check your comments, and whatever doubts you will have, I will be taking a doubt clearing session after few sessions where I'll answer your questions there, okay? So you need to mention them in the comments then if you will not be able to work on any question. So now what I'm going to do, I'm going to take some questions based on this, and I will be guiding you about the steps you have to follow. And after that, I'll give you time to work on it because you will have some time before the next session. Okay, so you will be checking it out, like whether it's gonna help you or are you able to get the right answer or no. Even I'll tell you which option should be correct one, so that you can verify and you can get to know are you getting it right or not. So give me a second, I'll be writing it. Your first question is here. So guys, we can't jump to the more advanced level directly because there will be all students we will have in the session. Some of them are just starting their preparation, so I need to consider everybody. I'll be taking more questions, I'll be taking advanced questions too, but step by step, okay? So patience is the key. If we have patience, we have the power to reach from here to the highest level. But if we don't show patience and we consider like, okay, I just want to be there just in a moment, so it's not gonna work that way, right? So here is our first question. The value of the integration over C, it's z cubed dz divided by z square minus 5z plus 6, where C is a closed contour. See, they have specified like, okay, it's a closed contour we are giving you. You can apply the Cauchy's residue theorem, you're free to do that. But if it is open, then what you will do, I'll be talking about that in the upcoming sessions as well, by taking the examples defined by the equation 2 mod z minus 5 is equal to 0, traversed in the anti-clockwise direction. Wow, they have given you the direction too, guys. They made it easy for you. And if in case in any question they don't show you or give you the direction, then you will assume it to be anti-clockwise. But even if in the figure they are showing you the direction, you have to consider that one, okay? Options are, I'm gonna write them here so that we will have everything on the one slide. Negative 16 pi iota, second one says 16 pi iota, third one says 8 pi iota, fourth one says 2 pi iota. This is what you are gonna have. Now you can start working on it if you want. I'll come back to this question to tell you its right answer and to discuss some steps. But even if somebody is there who wants to work on it, they can, or just proceed further. I think you have started, right? Now let me just tell you, if you will factorize the denominator, you can write it as z minus 3 and z minus 2. I think this will give you the same expression. So it will give you the z is equal to 3 and 2. Now you have to see in this pole, and you can see they have given you the contour this way. You can arrange it in this manner. Within the mod there is nothing else, so z minus 0 is equal to 5 over 2. So this is radius and this is center, okay? 0 is origin, is the center. Now you have to see is the 3 and 2 lying within the contour. If 3 is not there, leave it, but take 2 then after equating it with 0. Then find the residue at that pole. Okay, that is z is equal to 2. The order of the pole will be 1 because there is overall power 1. And then after finding the residue, you have to find the integration, which is 2 pi iota into sum of residue. The right answer you will have for this question will be option A. Okay, now you have to see, are you getting the same sign? Are you able to get like the answer which is correct? If no, we will be talking about it. You can mention it in the comments. In one of the upcoming sessions, I'll be discussing it. But the thing is, you need to click on the bell icon after clicking on the subscribe written below this channel or the video you are watching right now. Mission Net Physics exam, just check it out. Did you subscribe this channel? So basically, once you click on the bell icon, it shows you subscribed. Okay, so subscribed, is it showing you subscribed? Other than that, when you see a bell icon is there, click on this, and then you will find click all notifications you want to on. Okay, so on all notifications, so that for each and every video you will get the notification and you will not miss it, so that whenever I'll talk about the doubts, I will be discussing your questions or answer. Maybe in the next video I will talk about it if possible. You will be getting it, right? So you need to be regular. Now, next question after this one we will consider is here. This is question number 2. I need to mention it so that, and also guys, yeah, in the particular video comment section you will mention it, so I'll get to know you mentioned it in this video. I'll be able to get mention the question number. Okay, if C is the contour defined by mod z is equal to 1 over 2, the value of the integral is and then integration over C, this shows closed contour, the circle on the integration, dz over sine square z is, options are infinity, 2 pi iota, 0 and pi iota. Also guys, if we are going to talk about this question, here is a trick to solve it. Let me just explain. If you already know that what you will be doing, you can try it, and then I'm going to start the discussion. You can listen to that too, it may help you. So basically, if you will write the series expansion of sine z here, what it will be z minus z cube over factorial 3 plus z to the power 5 over factorial 5, and in this way you will keep on writing it, but you will have the overall square of the term, right? Then if there we will be considering the z is equal to 0 as a pole, because that is the only pole which will be lying within the contour, which is a circle having the center at the origin and radius half. So in that case, z is equal to 0 is the pole here, right? In this situation, when z is equal to 0 is the pole, then tell me if you will assume let the last residue formula I have explained you, which is this one. So let z minus 0 is equal to t, which gives you z is equal to t, right? So in this case, the coefficient of 1 upon t is the residue. Look at this. So in this case, you will not be able to get the coefficient of 1 upon t. Why? Because overall term square is there. So that coefficient we will say, okay, it's 0, because that term is not present there, means it's 0. When that coefficient is 0, means the residue is 0. When the residue is 0, so integration, which is 2 pi iota into sum of residue, must be 0. You got option C to be correct. So this question is providing you an idea like, okay, for any such case I can work smartly and I have to select what formula of residue will be giving me the answer quickly and easily. With practice and by working on the questions, everything will be becoming clear to you. Let's keep it this much today in this video. I would like to tell you something about the Unacademy subscription. So guys, we are having the different subscriptions available on Unacademy, like the Iconic, the Plus and the Lite subscription. But if you will take the Plus and the Iconic subscription, they will be helping you to like get all the benefits as you can see on the screen. And other than that guys, you just have to use and apply the code Anjali A Live as mentioned here on the screen, because by using and by applying this code, you will be able to get the discount in the total subscription amount. Even in upcoming days, many new courses by the top educators will be starting on Unacademy guys. So if you're the one who wants to attend the well structured, well planned courses sessions And even after taking the subscription, you will be able to join and attend the sessions by all the top educators we are having on Unacademy for your upcoming exam preparation. Also, guys, as you can see in the iconic subscription, you are going to get live mentorship, live doubt solving, interview preparation, all benefits which we are having in the plus subscription will also be there in the iconic. Okay, so in the plus subscription, you will be getting daily live classes, live tests and quizzes, structured courses, unlimited access. And again, if you are taking any of the subscription, use and apply the code Anjali A Live as mentioned here on the screen to get the discount in the total subscription amount and to join the well structured and well planned courses classes by the top educators. Also, guys, even now the notes are available on the learning app, which will be helping you to take your preparation to a very good level. Here we are having the difference between the different subscriptions. So you can clearly have a look at this. What is the difference between the plus, iconic, or the light subscription? And if you will take the plus or iconic subscription, you will be able to check out the important notes which are available on the learning app, which will be helping you a lot to take your preparation to the next level. You can use and apply the referral code Anjali A Live as mentioned there on the screen to get the discount in the total subscription amount. Also, guys, don't forget to share in the comments what you liked about this session, whether in short term you got to know so many important things, everything is clear, and even we will continue the contour integration discussion in the next session as well, so don't miss it. Other than that, what you found like okay, it can be improved, any suggestion, you can even mention that. Whatever is the doubt, mention it in the comments. Share it with your friends as much as you can, because it will be helping them to be regular in the preparation and to understand many concepts in the less time. Thank you everyone for joining the session and for attending it till then. Thank you. Bye. Take care. See you in the next